In this video, we're going to look at gradients as rates of change and try to understand what on earth is going on here. Okay, so up until this point, we've done gradients of straight lines like this. Y equals mx plus c, and we look at the gradient, which is this value here, and we can see that the gradient is, let's say, 2. Y equals 2x plus 1. Okay, this is very straightforward, something we've done hundreds of times, especially at this sort of grade 4 level. But what happens if instead of a straight line, we have a curve of some sort? Okay, how do we work out the change, the rate of change from a curve? Because the gradient tells us the rate of change. Okay, so if we have a look at a curve, what we have to do is we have to add in our own straight line called the tangent. Okay, we have to include our own tangent. Now, this won't be very accurate necessarily. Like we can try to kind of get this as good as we can. So there will be a range of answers that you can have for this particular question, but try to make it kind of relatively good. And we will work out the gradient of the tangent instead of the curve. So you would draw your triangle just like we always do and try to do your rise over run, or however you work out the gradient, y2 minus y1, all of those different ways. M equals the rise over the run. Okay, so a relatively simple thing to get your head around. If you want to work out a gradient of a curve, we have to put a tangent in. That's the first bit of knowledge you need to know. And this applies not just in maths. We use this in physics, chemistry, and biology a bunch. If you're doing rates of reactions or something like that, rate of radioactive decay, we would have to put a tangent on here in order to work out a rate. Now, why is this topic then such a high level if the only thing we have to worry about is to add a tangent and then do a normal rise over run? Well, your job in maths and for science is to interpret this value. Okay, let's say we do our rise over run and we get a number 10 over 2 and we get an answer of 5. Okay, well, what does that actually mean to have a gradient of 5? It means for every 1 we go across, we go up by 5. Okay, fine. Still don't see why it's so difficult. Well, when we're interpreting these, we have to include the context of the question. Okay, let's say this was time here, and I'll use a science example because it's exactly the same process. Let's say it's the volume of gas produced, centimeters cubed, and the time was in seconds. So this is your classic kind of rate reaction graph where it starts off really fast and then as time goes on it gets slower and then eventually it stops when the gradient is flat. Okay, if we work out the gradient at this particular moment in time, let's say that's 2 seconds in, okay, then what has the gradient actually told us? What we have to do is we have to interpret the units. What do I mean by that? Well, the rise, the y-axis, is centimeters cubed divided by the run, seconds. Okay, so we're doing the rise over run calculation, but with the units instead, or at the same time, I guess. We've got a number of 5, let's say. I've just made up the numbers, but let's say we've got an answer of 5. But then we'd have centimeters cubed divide per second. This is how we change this centimeters cubed divided by s into our unit to help us interpret the question. So in this context, we have this rate of reaction. Imagine you're reacting two things together. You're collecting the gas. At this particular moment in time, we have a rate of 5 centimeters cubed per second. Okay, so at that particular moment in time, we're producing 5 centimeters cubed of gas every second. Okay, so my best bit of advice for you is to, first of all, we learn just put the tangent on and do rise over run. Okay, that's the simple part. Then we do the rise over run calculation, but with the units, centimeters cubed on the top, time seconds on the bottom. And if we can turn that centimeters cubed divided by s into centimeters cubed per second, so that becomes per, this is how we can then start talking about the actual rate of change. What is actually happening in this context? Okay, so give that a go. Practice putting a tangent on and remembering to do the triangle, but then you can continue that by doing the calculation for the gradient and the interpretation with the units as well.